Mr.
Bond. James Bond.
And that's what this video is all about. Bond. We're going to learn a couple different types of bonds. But before we start, I wanted to give you a picture of what the periodic table tells us about how these elements bond. First of all, there's a staircase that runs right here on the right hand side, which separates out nonmetals from metals. And so everyone that's over here on the right side of the staircase is a nonmetal, and everyone on this side of the staircase, including all of these guys, these are all metals. In addition to that, everybody kind of like right in this vicinity and that way are negatively charged, and everyone on this side is positively charged. So for the most part, metals are positively charged, nonmetals are negatively charged, and we do have some exceptions that run in this area and we'll talk about later. But before we begin, I want you to understand two trends. One is valence electrons and the other one is charge. There are a couple of trends that you will have to memorize. Valence electrons, or the outermost electrons on an atom, the electrons that are responsible for bonding, have a pattern. Everybody in column number 1 has one valence electron. These guys have 2. Everyone in column 13 has 3 valence electrons. 4, 5, 6, 7, 8. So everyone in this column has 8, this column has 7. It's a trend. All of these guys right here, they're multivalent. They have different numbers of valence electrons, and we're not going to memorize those. Also is charge. Charge has to do with the electrons. Everybody in this column has a +1 charge. Everybody in column number 2 has a +2 charge. Everybody in column 13 has a +3 charge. Everybody in column 14 is going to be plus or -4. And then column 15 has a -3 charge, -2, -1, and the last column has a 0 charge. So we say 1 plus 2 plus 3 plus skip, 3 minus 2 minus 1 minus zip. So a bond is basically a force that holds stuff together. Okay, and we're going to talk about 3 different types of bonds. There are 3 major types of bonds. They are ionic, covalent, and metallic. All right. You can tell the difference between the bonds because ionic bonds are between a metal and a nonmetal. Covalent bonds are between nonmetals and nonmetals, and metallic bonds are between metals and other metals. The subatomic particle here that plays a role in all of this bonding stuff are electrons. So in the center of an atom I have a nucleus, right? There's some positive stuff there, some protons and some neutral neutrons. And on the outer part of the atom I have the negative part, which are the electrons. And these electrons, which are negative, are involved in bonding. So that's where we're at. We're on the electron part. Valence electrons are the outermost electron shell. So basically when I'm looking at this atom right here, I have an inner shell that has 2 electrons, and I have this outer shell which only has 1. So this atom has 1 valence electron. It has 1 bonding electron. It has 3 total electrons. So here we have the three different types of bonds: ionic bonding, covalent bonding, and metallic bonding. And your first job is to be able to tell the difference of what type of bond that it is. Remember, ionic bonds are between a metal and a non-metal, and covalent bonds are between nonmetals and nonmetals. Those are everybody that's on this side of the staircase bonded, and ionic bonds are between somebody that's on this side of the staircase and that side of the staircase. And metallic bonds, if I'm looking at the periodic table and the staircase, are between elements that are over on this side. So both elements or multiple elements will be just on the left side of this staircase. And different things happen in those bonds. In ionic bonds, the positive metal, usually, and this is sodium, and sodium's a metal, it's found right over in here, the electrons are transferred to the other element. So in this one, we have a transfer of electrons. Covalent bonds, if I look at this right here, this is oxygen, O2. The electrons are shared. So you can see here's one oxygen and here's the other oxygen, and they are sharing this pair of electrons right here. So covalent bonding between nonmetal and nonmetal, they share electrons. And in a metallic bond, the electrons are freely moving. They're what we call a sea of electrons. Electrons are negatively charged, right? And so if this were a aluminum baseball bat, which is just aluminum, a piece of, a solid piece of aluminum, it has little electrons just like moving around. They're not localized to just one aluminum. They're just moving around in there. And that's why most metals conduct electricity. The electrons are free to move. So a covalent bond yells at an ionic bond, "Hey, didn't anyone ever teach you to share?"